I just wanted to create this as a video so you guys could also see, if you didn't understand it when we went through class, have a little bit more time. And I don't know if we'll get through all of it in class. So when we have an equation, our goal is to get all of our variables together and all of our numbers together. And these are a little bit more difficult, but I think that's something we're going to be able to work through. And if you can get these, then the rest are going to be a piece of cake. So if I look at my equal sign, I'm going to draw a line down. And I want to get these variables here put together, and I can do that by adding like terms, which would be things that have just an x in. So x's go with x's, numbers go with numbers. So in this case, 3x and 2x, I take the sign in front of that, so positive 2x to get 5x minus 4 equals 36. This is what we call kind of our simple equation, where if we can get down to this, we want to be able to solve it from there. And then what we do is we do reverse order of operations. So I ignore my variable, I pretend this isn't here, and I want to get rid of a minus 4. The opposite of a minus 4 would be plus 4. Whatever I do to one side, I have to do to the other. So simplifying I can do on just one side, but if I'm adding or subtracting, multiplying or dividing, that has to be done to both sides. In this case, these cancel out. That equals 0, but I'm not writing 0 down because that just clutters everything. So 5x equals 40. 5 is attached to x by multiplication, and to undo multiplication, I divide. So I divide both sides by 5, and x equals 8. I can now put this 8 back into my equation using substitution, and that's a great way to check. So I'll just do it on this first one, but I won't do it on every single one. And sometimes it's just a matter of doing this in your calculator. I would do 3 times 8, which is 24, minus 4 plus 2 times 8. So I have 24 minus 4 plus 16, or 20 plus 16, which equals 36. And I check because this number and this number equal the same thing. So again, you could just quickly type this row here in your calculator, and then if you get the 36, you know you did it right. If you didn't, somewhere you made a mistake. Our second equation is very similar, where if I draw my line down the equal sign, that just helps me to know where I need to make sure that I'm putting things together. Negative 49 is by itself. The other side has a little bit of cleanup to do, so I'm going to put those together. When I'm combining my like terms, I have a 12x and a negative 3x. I keep that negative sign with the 3, so those two combine together to give me a positive 9x. And then the positive 9 and positive 5 are also like terms, so that would become a 14. Again, I'm back to that simplistic equation. And now what I typically do is I'm going to either add or subtract first and then divide. And that's like 90% of the time. So in this case, to get rid of the positive 14, I subtract 14 from both sides. And remember, these two cancel out. They're 0. That was the reason why I chose to subtract 14. Then I'm going to add the negative 49 and negative 14 together to get a negative 63. And I divide by the 9. So I want to make sure that I'm setting this up in a very organized pattern. And I have to make sure that I'm showing that I'm doing the same thing to both sides. Otherwise, things are going to get mixed up later on, and you won't necessarily always be doing things to both sides. Our last one on this top is, again, drawing down that equal sign because I only have variables on one side. 14 is all alone. I need to simplify this other side. And I need to distribute this 5 to both terms here. So I'm going to do that first. I did nothing with a 3x. I do 5 times x, which is 5x. 5 times a negative 2, which is negative 10, equals 14. Before I start doing anything with both sides of the equation, I want the one side to equal or to really come together. So I get 8x minus 10 equals 14. Again, now we're back to that basic equation. So I'm going to add 10 to both sides. I'm looking at taking care of things without my variable first. 8x equals 24. Divide by 8. X equals 3. So our summary here is that our goal is to get get the variable by itself, which in this case is all x, is to get x by itself. And then as we're working and getting x by itself, we are using order of operations in reverse. On this bottom one, it's kind of combining some different things we've been doing, adding on a little bit because now we have x's on both sides. The only thing is with x's on both sides, I need to get rid of one. It does not matter which one of the x's I get rid of. So I can get rid of a negative 2x by adding 2x to both sides. I can only add that x term to x's. or I can subtract 4x from both sides. I like to keep things positive, so personally, I'm going to go ahead and add in the 2x. If you subtracted 4x, it's not a bad thing. So 15 equals 6x plus 39. This gets me back to the equation like I had up above, where I said this is like your kind of your goal where you're trying to get to. And so now I would subtract the 39 and negative 24 equals 6x, and then I divide by the 6. It gets to be kind of repetitive after a while, which is a good thing if you start noticing that repetition. X is negative 4. Again, if you want to check, put that negative 4 into this side of the equation, get an answer. Put it into this side of the equation, get the answer. They should equal each other. If they don't, that means that there is something wrong with those. More of just the same. This one, I have to kind of clean up one side, so 13x minus 5 works. The 10x minus the 4x are like terms, so 6x plus 37. And then I choose to get rid of one. I'm just going to get rid of the minus 6x, because then my answer will be positive when I'm done, but there's nothing wrong with subtracting 13x. Notice I'm lining up these x terms directly underneath each other. That is really important to keep things looking good and figuring out things later on so you make less mistakes. The neater you can be with this, the better. And that's what I'm going to be looking at through class as well, is are you keeping things organized as you're working? Because if you're not, then that's going to become a problem for you later on when you're trying to do more complicated problems. And just kind of keep following through. So typically you're adding and subtracting and then you're dividing. Again, not always, but it's a typical piece. The next one, I need to distribute those. Just multiply those through to whatever's in there. Negative 7 times x is negative 7x. Negative 7 times negative 1, because I treat that as a negative, is a positive 7. And then negative 5 times x is negative 5x. Negative 5 times negative 5 is a positive 25. So now I just simply have a variable on both sides. I want to get them all on one side and my numbers on the other. And I can do that by adding 7x, or again, I could have added 5x. It does not matter. So 7 equals 2x plus 25. I chose to add 7x because that meant my, sorry about that. That meant that my 2x, I wanted this as my pointer. My 2x is positive. And if I would have added 5x, I would have had a negative number and had to deal with remembering to divide by a negative. And I just know sometimes I forget. So if I can keep them positive, life is easier for me. And then I'm going to subtract 25 from both sides. When I'm doing my videos, I like to put them in the calculator because I always mess up even if I know what the number is. So negative 9 equals x. So when you have variables on both sides, our goal, variables on one side, numbers on the other. This should go in your notes notebook so that you have some reference, you have some pieces that you can look at.